Hi, everyone. My name is Wusal Kerimli, and today I will be your moderator in this Pi and AI workshop. This is actually the first workshop that we will be organizing today, and we had some technical problems. That's why we're kind of late to start, but everything is taken care of. So today, we will be talking, let me first introduce our speaker. His name is Turgut Abdullayev. He's a chief data scientist at Neuroil startup. He worked at Access Bank and he's one of the experts in this field. Before kicking off the event, I just wanted to welcome you all. I see that there are many people joining from different parts of the world. Just want to say hello wherever you are. It's currently 7 p.m. here in Baku. It might be morning wherever you are. So just want to say hi and hello. We will start by a message from Andrew NG, and then we'll proceed with the workshop.
Learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together.
I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Jian, who recently created deep learning specialization. He's working on an exciting new project. So, do you want to tell the people at Pi AI what you're working on?
Yes, sure. I'm leading a project called Keras, focusing on helping people get offers in AI, navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
The AI field is new. Organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really important work. It's nice chatting. And now let's go chat with Motel, who is on their product team. You want to say hi to friends at Pi AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world, people like you.
What are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks also.
Thank you.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So, if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
Yes, we are back, and I would like to thank Mr. Andrew NG for the welcome message. And now I would like to give the floor to our speaker, to Mr. Turgut Abdullayev.
Thank you, Sal. I welcome everybody, and I want to tell that today we're going to analyze a BERT model and understand how one can apply this model to Azerbaijani language from R. So let's share the screen. Is it possible to share a screen? Have you saw?
Yes, it should be possible to share the screen.
It isn't possible, but it's disabled actually.
Screen share.
Okay, let me give you a brief information about BERT model. This model is proposed by Google Artificial Intelligence team, and this model has a unique feature which is called transformers. And via these transformers, the BERT model tries to understand the world based on its surroundings. And I would like to mention that there are different kind of BERT models, but the main difference between them is their parameters. Some BERT model can have, for example, 12 heads, 24 heads, and even more. Yes.
Sorry for the interruption. Could you please go ahead and try it again?
Yeah, thank you. And now I'm sharing the screen. It's possible. Yeah, here it is. Okay, as I mentioned, this model is proposed by Google AI, and it reads the entire word sequences at once. Because we know that usually deep learning models in natural language processing tasks try to read a sentence from left to right or from right to left, but BERT model tries to read the whole sentence at once and tries to understand word based on its surroundings. Let's look at this example. This example is taken from the official BERT paper, and we can see that there is from the top the input block, and there are two actual sentences. The first one is "My dog is cute," and the second one is "He likes playing." We can see that there are special symbols like CLS and separator. These symbols, the first one means that it's the beginning of the sentence, and the second one means that it's the separator between two sentences. From top to bottom, we can see that there are some embeddings, and there are actually three types of embeddings. The first one is token, the second segment, and the third one is position embeddings. So before explaining all these embeddings, let's first understand what's embedding. Embedding is just some kind of vectors which helps to understand, which helps to explain the word to the machine. So we can encode each of the word, for example, my, like 1, dog is 2, and etc. But encoding every word with just one number is not enough. So this is why embeddings are helpful. They help to represent a word not just only with one number, but at the same time it helps to give to each word, for example, 700 embeddings. This means that each word will have 700 dimensions. So instead of encoding each word with one number, we encode each word with 700 numbers. For example, if you look at the right side of our slide, we can see that token embeddings here has 768 embeddings. So we just encode every word with 768 dimensions. The next type of embedding is called segment. This embeddings helps to understand the semantic similarity between different parts of the sentences. For example, we can have at the beginning of the sentence a phrasal verb, and we can have a different phrasal verb at the end of the sentence. But in fact, they are synonyms. So BERT can understand that these phrasal verbs are synonyms, in fact. And the third type of embeddings are called position. These embeddings help to differentiate, help to understand that identical words at different positions can have different meaning. What does it mean? It means that I can say that the plays of Shakespeare are really fascinating. And I can say that my dog likes playing. There are two words and the same word is play. So the plays of Shakespeare have totally different meaning, and my dog likes playing is totally different, has a totally different meaning. So this means that the same words will not be treated as the same. So they will not be identical. So a BERT model can do all this transformation and can understand the sentences like a human brain. And in order to load a pre-trained BERT model, we have to load three types of files which are provided by Google Artificial Intelligence. The first one is the checkpoint. What checkpoint means? Actually, a checkpoint is means that the model has been trained by the Google AI, and they stopped the training process at certain time. So what actually we do is to continue build our model based on the pre-trained model. So checkpoint allows us to build our model based on a BERT model. The second file is BERT configuration file. This is a technical part of the BERT model because it contains, for example, the hidden units or the number of layers and etc. And the third file is vocabulary text. Vocabulary text contains some dictionary, and this dictionary belongs, and this dictionary helps to separate words in the given sentence. For example, look at our input. Please look at the input sentence. You can see here that the first part of sentence is "my dog is cute," and the second part is "he likes playing." You can see that BERT model separated the playing word by a suffix. So it just basically removed the suffix. It's very helpful. Why? Because play word and other different words can have different type of suffixes and prefixes. So when we remove a suffix or prefix, it's very helpful for a model to build some kind of state-of-the-art model. So, because if you use the word playing and play, for example, or even plays, and many other different forms, then it will be for BERT model to differentiate these words. So removing a suffix or prefix will be very helpful. Next, let's look at the code chunks, which I provided here. you can see that the first code chunk is about loading model from checkpoint. And here just, as I mentioned, you show the configuration path and the checkpoint path and allow a BERT model to train your model based on your data set. Here we can see an interesting parameter which is called sequence length. What does it mean? For example, you can have 10 words in your text, and you want and the second, for example, your first text is about 10 words, and your second text is about 20 words. So you have a different length. So your choice is to have the same length. In order to do that, you should provide the sequence length in order to make them the same. Later, we can see the second chunk, which is about steps. What does the step mean in BERT model? For example, imagine that you want to read a book and you try to read it page by page. So first day you can allow yourself to read only the five pages in the book, but over time you can increase your learning rate and read, for example, 3 times more than usual. So you are basically increasing your learning rate. So you can see here that there is so-called warm-up steps. This means that the same as I mentioned, the model will gradually increase its learning rate and will try to update its weights at lower pace. Later, when it reached some kind of, how to say, stable state, it will try to not to increase its rate, but instead it will begin to decrease its learning rate because it has learned a lot, and now it's time to slower its learning rate. Because if it continues to increase its learning rate, then it can how to say it can harm the model, and the model will not be powerful. Later, as always, with Keras model example, you have to compile your model and include here warm-up and decade steps. And you just also can provide, you have to provide loss function and metrics. As a metric, you can now provide area under curve metric from TensorFlow. As you know, Keras is now inside TensorFlow. You just can put the tf dot Keras and dot metrics and dot area under curve. And later you have to fit your model. You can also find the whole source code on our GitHub page and detailed explanation on blog data experts. This is my official GitHub page and official blog. But we have mentioned here only parameters of BERT model. But let's look at our data set and understand what's going on in our data. Well, in order to build a real-world case, we scrape data from internet, and as you see that there are some comments in English, in Russian, in Turkish, and in Azerbaijani. As we use a BERT multilingual model, we will not have some issues with our input, because our input has a lot of text in different languages. So BERT model understands basically over 100 languages. So to have different kind of languages will not be difficult and will not be challenging for our model. You can see here that the first comment is in English, and it's about taxi service, and our target is 0. What does it mean? This means that the provided text is not negative. It's positive, actually. In machine learning, usually 0 means positive and 1 means negative. The second provided comment is in Russian, and it's encoded as 0. This means that we have the same class. This means that our target is positive. And the third comment is in English, and it's a negative text, because we can see that there is a person who didn't like the taxi service. And the fourth one is in Azerbaijani, and again, it's a positive comment. And what's interesting about fifth sentence, you can see that the first part is in English and the second part in Russian. So even having this kind of text, which is not only in the first part is in English and the second part is in Russian. So it will not be a problem of our model, because it can differentiate over 100 languages. After applying this model to our dataset, which has 4 different languages, again, Azerbaijani, Turkish, Russian, and English, we built our model architecture with Keras and trained only one epoch. And after one epoch, we get a great result, because area the curve was 0.94. Area the curve is a very powerful metric if we want to differentiate 2 classes, and in our case it's a binary classification model, because here we want to differentiate 2 classes, positive and negative comments. And I would like to again mention the fact that if you want to
now discuss the all-in-one solutions. So this is a lot of stuff, right? That's a lot of detail, kind of hard to get a handle on all of it, and you might be stuck with a bunch of point solutions to all the parts of this problem, which might be annoying to manage, might be expensive,
Yeah, I'm hearing you. Do you have a question? Do you hear me?
Turgut, I guess there was some kind of interruption. Do you want to go on with your presentation? And we will have a Q&A session once your presentation is over. So we will have some time for questions as well. But now, please go ahead with your presentation.
Thank you, Vishal. And again, I wanted to mention that in order to, if you want to get a full source code, you can visit the GitHub account or just visit my official blog and see the whole point and the whole technical part of implementation of the BERT model. I think that's all. We can now have questions from listeners.
Yes, now we can move to questions. So if you have any questions, please go ahead and ask Turgut about it.
The language identification, is that based on character set or vocabulary or a mixture? And if someone, sometimes you can speak a language using a character set that's not the native one. So would it pick up that type of translation?
I want just to clarify your question. Are you talking about the problem that it will not understand the letters of the word, or maybe it will try to translate a word? Could you a bit elaborate your question?
Sure. People use non-native character sets all the time to, for instance, there are transliterations from Chinese to the Latin character sets. I think they're called romanizations. So they'll spell out a word that's in, it's typically written in ideograms, but spell it out as syllables and then put special marks to say whether the inflection is rising, falling, smile, like all various inflections. But if you look at that and you know what the encoding is, you can recognize it as Chinese, and people can look at that translation and pronounce it, but it wouldn't necessarily look like the text of some Chinese text in a corpus. So that's the question. Is there a layer of abstraction that would be able to translate a transliterated language?
Thank you for your question. Now I understand it. I think it's again based on vocabulary because BERT has a vocabulary and it tries to split a word only based on this vocabulary. So if it, for example, the word, if I don't have word choose in English, just an example, it will try to find this word, for example, in Chinese, maybe in Azerbaijani. So in fact, it will treat this word as Azerbaijani if it's not able to find this word in, for example, in English or in Chinese. So this means that, for example, the BERT model will understand the word in the wrong way. But despite that, it will still give you a great performance because it's already on internet and you can find this information and get for information about that.
May I ask the question?
Yes, sure.
Yeah, hi, Turgut. Thank you for the presentation. So amazing. I liked it. Can you tell me a little more about the training procedures after you downloaded the model and region, if you can go beyond one epoch? Because I see that accuracy is around 93% here. And was there any reasoning behind having training for shorter, or like your insights about the training in general from the BERT model? Thank you.
Thank you for the question. Actually, I participated a lot in Kaggle competitions, and in that community, we noticed that if we try to increase the epoch number, for example, if we try to iterate the training process over 3 or 4 times, we get a very bad result. So this means that it's really enough to train the model only for 1 or maximum 2 epoch. So this is just some kind of experiment, and based on experiment, we can see that it's enough only train 1 or 2 epochs.
Okay, I see. And was there any limitation on the data set which you used, or has that also a reasoning with the epoch length? Because I believe that if you use, say, large corpus, I think you can increase the training. I'm not sure. I'm very new to NLP problems for sure.
Yes, actually, again, during Kaggle competitions, people from English language training in English, the BERT model, they can get the area under curve score almost around 0.98. It's very high. But even with, it's really fantastic because we could get the results near how to say English version of BERT, because English version BERT is around 0.92 99 or 98, but with multilingual, we again could achieve astonishing results because our R&D curve is 0.94 almost. And we just trained the model only for one epoch. I think 2 epochs almost also would achieve a very good results. So it's only about like experimenting with our model.
Okay, yeah, thank you. With multilingual problem, it makes sense and great results. And just a little like another comment that can you share the your source code link in the chat so that we can see, and your blog as well. Thank you.
Yes, of course. I will share the GitHub page and also the link for my blog. Thank you so much.
I have one question for you. Thanks, Turgut, for presentation. And how we can use BERT model for open domain question answering or closed domain question answering model. I think there are some ways to use it in question answering models, developing question, QA models.
Thank you for question, Eldanis. Yeah, we can actually train any kind of model with BERT. For example, you can build a binary classification model. You can build a multi-classification, or you just can build a question answering model. In order to do that, you just have to extract the output layer, and then using a functional API of Keras model, bind the inputs with outputs. And you should first extract output, then add additional dense layer. For example, if you have, for example, in our case, it was a binary classification model, so we added just dense layer with 1 unit. And as an activation function, we chose sigmoid function. So our probability ranged between 0 and 1 because we have binary classification model. So in your task, you can just again extract the output of BERT model and add additional layers.
Thanks for answer, and also that's a great presentation for us, for me, I think.
Thank you so much, Dennis.
Do we have any more questions? Please feel free to ask.
I don't have any question, but I just wanted to like have a comment that can we get the copy of presentation as well? I really like the first 2 presentation, especially. Thank you. Like the first 2 slides of the presentation. And if we can discuss more on that, if we have time, that would be great.
Yeah, sure. I will share with Wissal, and I think he can help to share the presentation with everyone.
Yes, definitely. We can share it with all the participants. And I think Mr. Johnson has a question.
Just how long? This is sort of a case of transfer learning. How long is the particular phase, the phase where you're training from the checkpoint, compared to the overall training time, or I guess I should say time and computing, because the time on single CPU isn't the same as the time on a gigantic GPU. But just order of magnitude, is it 90-10, 50-50? What's the relationship between the up to the checkpoint and after the checkpoint training in terms of compute effort?
Well, actually, thank you for a question. Actually, the model was already trained by specialists from Google. We just take the model from checkpoint, and as you mentioned, we implement some kind of transfer learning process. As our model, as our dataset was not big, for example, there were around 2,000 comments, and we load the model and trained. So training on CPU just took one epoch took around 20 minutes, 15-20 minutes on CPU. And actually, I have Mac from 2015, and it took around, as I mentioned, 15-20 minutes training just only for one epoch. I think with GPU it will be way faster.
Okay, if the yes, Mr. Johnson, go ahead.
Thanks. Well, so this is a great savings when you compare how long it would take to train the entire model from the beginning. You know, just the amount of energy consumed. It's you know, starting from the checkpoint is tremendous. You know, I mean, it's probably enough that if enough people are doing things like this, it's making a impact in energy use on the planet. Just an observation.
Thank you.
Okay, if you guys don't have any questions, I just wanted to briefly inform you about an update. So this event actually marks 100th event of the Deep Learning's AI. So to celebrate this, the head office decided to send out hoodies with the Deep Learning AI logo on it to the persons who will answer this question. So we have 2 questions. We will ask them, and the first person to answer the question will get the hoodies. So, Turgut, would you like to go ahead and ask the questions?
Yeah, sure. Thank you, Sal. We have actually 2 questions, and the first one is, what's overfitting in machine learning?
Can I answer?
Yeah, sure.
Overfitting is the training model on, I think, based on dataset. You train your model over and over again, and this is fails in the test set. And I think overfitting is the training your model based on dataset, but there's overflow in the data in your model.
Yeah, I think Eldanis is right. Thank you so much for your answer. It's some kind of when we split our data into 2 groups, because during any training in machine learning process, we split our data set in 2 groups, the training and the test set. So during training, we use train set in order to train our model. So during training process, our model can learn some unnecessary moments which the model cannot confirm on test set. So this is why so when it fails, we call it overfitting. And I would like to ask the second question, and my question is, what is an imbalanced dataset?
Can I answer it?
Yeah, sure.
Okay, so the question is, what is imbalanced dataset, right?
Yes, that's right.
So like if you have a data set for, say, binary classification or say multi-class classification, if your data is like imbalanced in one way or other, for example, if you have, say, positive and negative reviews for an app, you might have like positive reviews like 90% and 10 reviews of a negative, 10% data of negativity. So because of that, your loss function gets biased on your positive reviews, and you might have, in the test time, you might have higher chances that your any given review would be positive. And it can have detrimental effect on the multi-class classification, because then your one class can have really high weight on your prediction of the model. I believe so.
Yes, thank you so much. That's right. When we have unequal distribution, we have an imbalanced issue with our data. Thank you so much.
Just a quick note. So I shared my email address in the chat section. So Mr. Tak and Mr. Babayev, if you could just go ahead and email me your sizes, your hoodie size, and also your mailing address, so that we can ask the head office to ship it directly to your address. Thank you. And if you have some more questions, please feel free. We have, I think, we started a little bit late, so we have 5 more minutes. So if you have any more questions, please feel free to ask.
Actually, I'm just trying to share with everyone the links from the presentation. Just 1 second. Yeah, here it is. Yeah, here's the link from the given from the presentation. So you just can open this link and see the full source code.
In the chat? Yes, go ahead, please.
I just want to ask one question. Have you heard about Albert? It's the newest version of BERT. I wanted to ask you if you heard about it and if you know some differences between the newest version of it and this, or if you have an experience with that. Thank you.
Thank you for your question. Actually, from our community, we have never tested it. With Python, we have a lot of examples how one can implement Albert model. I think the main difference between BERT and Albert is that Google AI tried to how to say decrease the number of parameters inside the model, and when it decreased the number of the parameters from inside within the model, they could achieve the same accuracy, and they could receive an accurate model, and without hurting the BERT performance. So at first, many people thought that if we remove some parameters from the model, we will not achieve this state-of-the-art result. But despite that, Google still could achieve this result. And I think that the best way to implement Albert model is to use TensorFlow Hub. This is a place where you can download the Albert model, and there is also a tutorial how one can train the Albert model. It's very how to say, it's not complex as BERT model, and it's a light version of the model. So with TensorFlow Hub, you can easily download this model, and again add your dataset to the top of the model and train your data.
Thank you. But would you recommend it, or would you stay on BERT? Like
thank you so much. Actually, I would highly recommend. In fact, right now I don't have so much time to implement that from R, but I am planning to write a new tutorial how one can apply an Albert model using TensorFlow Hub.
All right, thank you for the answer.
Thank you.
There's a question in chat section from Mr. Johnson asking about the Coursera code. I think it's a 50% discount code. I just wanted to mention that after this event is over, you will receive an email from the head office about the post-event survey. And once you complete the survey, you will receive 50% discount codes for all deep learning courses on Coursera. And I think we have 1 or 2 more minutes. So if you have any more questions, we can take one last question and then we will wrap it up.
Like if you can share a little bit more insights on the first slide, especially. Can you go on first slides, please?
Yeah, sure. Just 1 second. You mean this one?
Yeah, this one, sir. Yeah. So, I mean, I wanted to know more about the difference between the segment embeddings and the position embeddings. The token embedding is quite popular, but just a difference.
Yeah, here's actually in presentation, you can see that I gave just some quick explanation of segment and position embeddings. The segment actually tries to understand the semantic similarity. What does it mean? Actually, if you look at this segment embeddings on the right of our presentation or our slide, you can see that the first part is encoded and E and with A, and the second one is B. So it just tried to understand how similar is the first part of the text to the second part of the text. And position embeddings, just as I mentioned, for example, again, I can say that the plays of Shakespeare are very interesting. And I can say that my dog likes playing. So we are using the same word play, but plays Shakespeare are not the same with the my dog likes playing. So a BERT can understand that these words are not the same. But if you take any other model, except BERT model, it will not understand the meaning of the word, because it will treat the meaning of the word the same. So like playing means, for example, only verb for any model except BERT.
Okay, thank you. So, and the segment, say A and B, are decided for the each sentence. For example, in this case, when we have separation token, that's where your segment should change.
Could you a bit elaborate your question?
Okay, so I didn't see or say didn't pay attention about the section A and B before. So in the segment embedding, so EA is available from say first token, which is start of the sentence, to the separation token, right? And then your next segment starts from say he likes playing, the complete sentence. So is it based on the sentence to sentence, or is there any like particular instance where your segment embedding changes, for example, but or and or even comma in the sentence?
Yeah, actually, I would say that as you see that there are special symbols on the part of input. For example, the first symbol is C, L, and S, and the second one is separate. This means that this is the first sentence and this is the second sentence. I would say that separating means dot. For example, this is the separator here means that this is the ending of the first sentence. So after that, if the sentence ends, it will treat that as the first sentence and the second one as the second sentence. Then it tries to understand how the first part is similar to the second part. For example, the BERT model here can understand that my dog, and dog here means he. Because on the second part, you can see the word he, and on the first part, you can see the word dog. So dog here means he. So BERT model can understand that dog here means he.
Okay. Yeah, thank you. I mean, so since the embedding changes on the separation token, I assume, and I can read more later, that it changes when there is an end of the sentence, I believe.
Yeah, it's again,
okay, thank
it
you.
works. It just works based on the symbols, because dot means like the ending of the sentence.
Okay, thank you so much. Yeah, thanks a lot.
Thank you. Also, I would like to mention that there is a package called BERT visualization. It helps to understand that, for example, if there are 12 layers in our BERT model, you can extract each label from each label the attention mechanism. So, for example, what does it mean? It means that if you put the link on the word my, it, for example, can high attention with the word he. So you can understand that and see that BERT model understands that dog means he, my dog means he. Without my, only just dog. Dog means he. So via BERT visualization, you can understand actually what the BERT model see in your data.
Okay, nice. Thanks.
Thank you.
Yes, and I think the time is over. I just wanted to thank everybody for taking your time and joining our workshop. I hope you enjoyed it. And thank you so much, and stay safe. Bye-bye.